Welcome back. In this lesson, we're going to identify proportional and non-proportional relationships in tables. So we're going to make a table and see if the relationship between the two items in the table is proportional. This is Lesson 3 in Module 1 of the 7th grade book. In this example, I've been hired by our neighbors to babysit their children on a Friday night. You are paid $8 per hour. They want you to complete the table relating your pay to the number of hours you worked. So $8 per hour means $8 for every 1 hour. So if you work 1 hour, you're going to get paid $8. If you work 2 hours, you're going to get paid 2 times $8, which is $16. If you work 3 hours, you're going to get paid 3 times $8, which is $24. 4 hours, 4 times $8 is $32. 4.5 hours is going to be $36. 5 hours will be $40. If you were to work 6 hours, you would get paid 48 hours. It's interesting here, we can see as these are going up by 1, the pay goes up by 8. It's like skip counting. Here's another example where the number of hours goes up by 1 and the pay goes up by $8. The halves are interesting. It would go up half of 8. So from 32 to 36 is 4, which is half of 8. And from 6 to 6.5, we go from 48 to 52. 6.5 times 8 is 52. Now in this table, we can tell that the pay is proportional to the hours worked because we can find the value of each one of these ratios. If we find the dollars per hour for each of these, $8 for 1 hour is 8, $16 for 2 hours, 16 divided by 2 is 8, 24 divided by 3 is still 8, 32 divided by 4 is 8, 36 divided by 4.5 is going to be 8. 40 divided by 5 will be 8. 48 divided by 6 is 8. And 52 divided by 6.5 is 8. Each of these ratios have the value of 8. So we know that the pay is proportional to the hours worked because the value of the ratio for each of these is the same. When we're dealing with tables, that's always going to be the answer. We're always going to look to see, is the value of the ratio the same for each ratio? If it is, then the relationship is proportional. If it's not, then the relationship is not proportional. Let's look at exercise 1 together. In this table, we're comparing the time in hours to the snowfall in inches. We can see that in 2 hours, there were 10 inches of snow. In 6 hours, there were 12 inches of snow. After 8 hours, there were 16 inches of snow. After 2.5 hours, there were 5 inches of snow. And after 7 hours, there were 14 inches of snow. We want to see if the snowfall was proportional for each of these. Did we have the same rate of snowfall in each of the 5 counties? We're going to be comparing inches per hour in this relationship because time is almost always on the bottom of a relationship. So in our first county, we had 10 inches in 2 hours, which means our rate was 5 inches per hour. In the second county, we had 12 inches in 6 hours. If we divide that, we get 2 inches per hour. That was the rate of snowfall in that county. In the third county, it was 16 inches in 8 hours. If we divide that, that's 2 inches per hour. Now that's the same as the second county, but not the same as the first one. Our fourth county had 5 inches in 2.5 hours. If I divide 5 by 2.5, I get 2 inches per hour. And in our fifth county, we have 14 inches in 7 hours. 14 divided by 7 is 2 inches per hour. So if we look at all of our rates, all the values of our ratios, all of them are the same except for the first one. That has a different ratio, a different value of its ratio. So we know that this relationship is not proportional for all the counties. We would say the amount of snowfall per hour is not proportional for all counties. And that's because not all of their values were the same. In class, you're going to work on the rest of the exercises and the problem set, and we'll finish this off. Make sure you watch this again if you need to. Fill in the information for the example and the first exercise, and we'll see you in class.